Hello everybody, today I'm back with another video, and today I'm going to be covering a calculus topic. This is called Telescopic Series, and yeah, so let's get right into it. So this applies to a very specific type of series. This doesn't apply to every single series that you work with, but it does apply to specific types of series, and that specific type of series are series that have you can that kind of look like this right here, which have maybe a polynomial or a quadratic, which is also a polynomial, on the denominator of this series. So if we just try to solve this normally, and we're going to say that maybe n goes to infinity, but we're just going to leave it as n for now. We can consider n infinity later. So for now, we're just going to imagine that this is a finite sum series. So what would the first term be? So we have 1 over, and we're going to start with 1. And that's going to be, 1 times 1 plus 1, which is just 2. So we got 1/2 as our first term. And then for the next term, this would be 2. And then we'd go to 2. Okay, that's going to be like that. We can keep on going. We're just going to put in 3 here. And of course there's going to be 1. And this would continue on. You can sort of get the trend. And it's going to go until n. So we're going to do it for n minus 1. So we got n minus 1. We got n minus 1 plus 1, which is just n, but not going to simplify it right now. And we have, for the last value, which is going to be n, we are going to have n times n plus 1. That is going to be 1. So this is how the series would add up, and since it's increasing, the denominator is increasing, and the numerator, forgot the term there, is not increasing. This means that as a whole, this is decreasing, and this could be converging to a point, and actually it is. But what does it converge to? And this is something that your calculus teacher might ask if you're taking a calculus class. So we are going to try to answer that question. And obviously you could solve it the traditional way, but with a telescopic series, what you can do is actually use something, you can use a topic that you may have learned in pre-calculus. So before you took calculus, you may have recalled partial fraction expansion. Yes, that is the term. So what is partial fraction expansion? So this is a little quick review, and I'll link the video. I have a video on this. I'll link it in the cards up above and the description for this video. So I'll link that. So as a quick little refresher, what we're going to do is we're going to separate this. We're going to expand it into its partial fraction. So we have 1 over n plus 1. And for partial fractions, we know that the two parts have to be the denominators of this and n plus 1. And with these, we don't know what they're going to be at the moment. That's what we need to solve for. And if this interests you, or this piques your interest, and you want to know actually like how to do it in a bit more in depth, I'll just click on the link to the video. I made this like a while back, so yeah. So once we have this right here, all right. Once we do that, we can start solving for a and b. So what we're going to do, we're going to multiply n by every term here. So what's that going to do? This is going to, first of all, remove n here. We're also going to remove n here, but it's going to bring n over here, times n. Then what we're going to do, we're going to do n plus 1. So this is going to make n plus 1 come up over here. We are going to cross out this n plus 1 over here. So then we're left with 1a n plus 1, and that's going to be plus b n, and I'm just going to put parentheses. And what we have also, to solve for a and b, notice we still have 3 variables. We need to have one variable to be able to solve for any of them. So how do we do this? Well, let's make this term, the term in the parentheses, one of them, equal to 0. So first of all, let's try 0. Let's set n equal to 0. What does n equal to 0 do? So if I were to make n is equal to 0, that would be 0 plus 1 and b of 0. So this would just cancel out. That's not going to be there. But we have a right here. 1 is equal to a, or a is equal to 1, whichever way you want to say it. And then what we can do, we can go back. So we know that, I'll just keep a little note up here. 1 is equal to a. Sorry for the handwriting. And then we're going to go back right here. I'm going to erase this part right here. We're going to do the same thing again for b. So we got a of n plus 1 plus b n. And this was equal to 1 if I remember correctly. And alright, so then we have to set this term equal to 0 and this term equal, we need to find out what b is. So we can set it to minus 1 and see how that works. So we go with 1 is equal to a times minus 1 plus 1. This is just going to be 0, and that cancels out this whole term. Plus b times minus 1. So we got minus b is equal to 1. I'm just bringing this all here. And that makes b equal to 1. Oh, sorry, minus 1. Minus. And so now that we know that b is equal to minus 1, let's clear this up for some real estate. Clear that up too. We know that b is equal to minus 1. Now we have an expanded version of our original fraction. So I'm just going to rewrite what we had originally. And actually, I'm just going to show you because I still have it here. And we have this series right here, and we've just expanded it. So I'm going to rewrite it right here. Plus, we have n. We have n plus 1. And we just got a and b. And a we put here. We put 1. And this one was negative 1. And if you want, you can switch this out as well. So now what can we do with this? What does this solve? Does this do anything? You said that this was going to be easier. Well, I said it was going to be easier, and I'm going to show you how. So we have here, so we're going to recalculate it again, similar to how we did it here. I still have the steps here. This is how we did it originally for the series. And let me do a little gallery walk, a little slower this time. Now what we're going to do, we're going to do the same thing essentially. We're just going to solve it, and look out for any patterns. So we're going to do 1, n is equal to 1. And so we got 1 over 1 minus 1 over n plus 1. That's going to be 1 over 2. And this is going to be the first term. This is the first term. Next, we put it in. 1 over 2. And sorry for this little mark right here. Minus 1 over 3. Let's put parentheses to denote that this is a new term. Plus 1/3 minus 1/4. If we go back and check that, n is equal to 3 in this stage, and then 3 over here as well, so that's going to be 4th. And you may notice a pattern here. We see 1 over 1, 1 over 2, minus 1 over 2, and then 1 over 2 again, and then minus 1 over 3, and then 1 over 3, and then minus 1 over 4, and this series keeps on going until n, however long that is. So that means this would eventually cancel out all the way until the last term, and I'm not going to do the term right before it. Actually, I should. So this is going to be the term right before it. This is going to be n minus 1. 1 over n minus 1 minus n minus 1 plus 1 over 1. 1 over that. Sorry. And we'll just do it on the next line right here. This is the nth term. 1 over n minus 1 over n plus 1. So, what do we get from here? You can see that this cancels out. And that just becomes n. Now notice that all the way, with the exception of this part of a term right here, and this part of a term, if you were to actually write this whole thing out, all of these terms would cancel each other out. You'll notice like minus 1/3, 1/3. These would cancel out. Half minus 1/2. These also cancel out. And it would keep on canceling out all the way to n. This means that the sum, the sort of, how do I describe this? What this series converges to is 1 over 1 plus 1 over n plus 1. And if I remember correctly, that this is actually minus. So that is what it will converge to. Now we don't know n, and most of the times in calculus you deal with infinite rather than finite. So how would you solve it in this case? Well, you can just take the limit as n approaches infinity, and that as n approaches infinity right here, you get 1 over infinity plus 1. That's just infinity plus 1 is going to approach 0, and 1 over 1 will approach 1. So this will approach 1, this will approach 0. 1 minus 0 is just 1. So that means that as a whole, this series will converge to 1. I hope this helped you guys. Well, if it goes to infinity, by the way. If it were to go to a different value, it would be 1 minus whatever this 1 over n plus 1 here, whatever that is. Anyways, guys, thank you guys so much for watching this video, and I know this was a bit longer than normal, but it's kind of a big topic. It's called Telescopic Series, for those of you who may have zoned out and forgot. But thank you guys so much for watching. Please leave a like and subscribe, and please do check out the integration by partial fractions video that I made. It is relevant to this topic. I used it for a majority of this video. And yes, so that will be it. Thank you guys so much for watching.